So here's the lecture question. You're given a file. You have to open the file, read it by lines, split the line on hashtags, and then convert these string values into integer values, sum up the integers, and then return that value. So a good mix of topics that we're studying. A lot of 115 topics in there that we're doing in Scala. So let's learn how to do this and a little bit more. We'll also cover data structures today, and data structures will be on the next lecture question on Wednesday next week. So let's talk about some types. We have quite a bit of types that we're working with. They're very similar to the types you've worked with in 115, but we'll expand a little bit on these. We'll have to get a little bit deeper into the understanding of these as we go throughout this semester. So I'll cover just a little bit on each one of these today. Int, short for integer, is any whole number or any integer. If you're familiar with that terminology already, you should be with int. But these are whole numbers, so no decimals, just like the ints that you've seen in 115. What I want to expand on a little bit is these ints are represented using 32 bits. So we only have a certain amount of precision that we can have with these integers. With 32 bits, one bit is used up as a sign bit, so we can only go from negative 2 to the 31 up to positive 2 to the 31 minus 1 because we need one value to be able to store 0. So we only have this fixed range where we can store integer values using the int class. There is a 64-bit version of this called long. If you're going outside of that range, you know you're going to be outside of that range, you might want to use longs instead and go up to 2 to the 63 minus 1 in the positive direction. 2 to the 63 in the negative direction. If you're going outside of this range, we call that an integer overflow. You're going to overflow your int, and what happens when that occurs is probably something you don't want to happen. It's going to wrap around. So if I have the highest possible positive value and I add 1 to it, now I have the largest magnitude negative value. Almost certainly not what you want in any case. It'd be a very rare application where you wanted this feature. So you have to be careful using ints. If you're going to overflow an int, just know that you're running that kind of a risk. If you know you're having values that are likely to be outside of this range, think of a different class to use, think of a different value to be able to store your numbers in there. Next is a double. Doubles are 64-bit representations. You've seen floats and numbers in Python and JavaScript. Double is any representation with a decimal, similar to float in Python. So this 64-bit representation is still truncated. So since we have to use only 64 bits to represent this number, there has to be some rounding at some point. If you think in decimal, how do we represent the value 1/3 using 64 bits? Well, at some point, we're going to write a bunch of 3s and then truncate those 3s. Say we have 64 decimal digits that we can use. We're going to truncate those 3s at some point, which will have some inherent rounding. Same thing with the computer. Any double that's represented in the computer will have to have some rounding at some level. And you might think, well, if I have a value like 0.3, as we'll see on the next slide, if I have a value 0.3, I should be able to represent that exactly. Unfortunately, that's not the case because in binary, everything has to be powers of 2, and we can't represent 0.3 as a power of 2. So even things that you would think, well, this has to be able to be represented exactly, it's not necessarily the case when it's represented in binary. And you can see we have, for the double values, we have an 11-bit exponent, so there's a limit to how large the exponent can be and a limit to how much precision we can have on the fraction amount as well. And then it's represented, you can think of this as scientific notation. It's this value raised to this power, and then 1 bit for the sign. So there is a loss of precision at some point. And we can see this, it occurs in even very simple math. If I take 0.1 and multiply it by 3, I don't get 0.3. Where this comes in critically in our code, especially once we start testing and running unit tests, if I expect this to be 0.3, which I normally would if this were a math class, that is 0.3. If I expect that to be 0.3 and I have a test that says check if c equals 0.3, that's going to return false because it's not 0.3, it's 0.300004. That's not equivalent. It should return false, and it does return false, so I get false on that check. So if I had this in a test, I'm expecting that to be 3, my test fails, I'm going to pull out my hair trying to figure out what's going on if I'm not thinking of this. What we do instead, whenever we check equality of doubles, we're going to see if the difference of the absolute value of the difference of those values is less than some very small value. Usually 0.00001 is going to be enough. These rounding errors are going to occur way down here at the end of the precision for a double. So we give it a very small value and just say if these doubles are within this very small value of each other, which we usually name epsilon. If it's within epsilon of each other, then we're going to call them equal. So when you're testing code and testing if those doubles are equal, always use at least something like that. Keep this in mind and check if the difference is small enough between those values. So those rounding errors, this is something in programming, this is just something we have to deal with. The computer can't represent these numbers exactly. Just think of all the consequences of that and make sure your code can handle those rounding errors, because they will occur. And in certain programs, if you're iteratively computing something, this rounding error can really add up. So that's something to be aware of. We won't have situations like that in this class where that will really come up, but something to keep in mind down the road. When you have these rounding errors, you're going to lose precision over time. Think of something like a bank computing compounding interest every second or so. If they're sloppy about how they do that, they're going to lose a lot of money or gain a lot of money and get a lawsuit, eventually lose it. Boolean is just what you would expect, true or false, lowercase t, lowercase f. If you don't have lowercase t or lowercase f, our IDE is just going to yell at you and you'll be able to fix it really quick. Boolean behaves just like you would expect from other languages. Unit might be new. This is our representation of nothing. This is something that we don't really need in Python or JavaScript, but if you're coming from Java, you've seen void. This is the same as void in Java. We need this in Scala because we have to define the types of our methods and functions. And if we have a method that doesn't return any value, that we only call for its side effects, then we would say that method returns void because just to indicate that it doesn't return anything. But we need a type there, so we just need some placeholder, so we put unit there. They decided unit is the word we should put there.
Can unit be the same thing as null? Like, can you say...
No, so unit and null are two different things. So null is something that is no value, and unit is this method, a way to indicate that this method doesn't return a value at all. But null, you could return null, and it means I'm returning something that's nothing. So subtle difference, but a little bit of difference. In Scala, we'll tend to avoid null as much as we can. Is a point of community guidelines, stylistic choices. Just the Scala attitude is never to use null. We may use it, we'll use it when we get to linked lists, but we'll try to limit how much we use it. So the two methods that we've seen so far, main and println, aside from the methods that we wrote, main and println both return unit. These methods are not made to return anything. They're just there to have side effects. Println has the side effect of printing something to the screen, displaying it to the user. Main has the side effect of actually running your program, but it doesn't really make sense for main to return anything. Who's it even going to return it to? It would return it to the OS, and it's just something we don't use. It doesn't need to return anything. Strings, same with JavaScript, Python, Java, any other language. A string doesn't strictly exist as a special type. A string is a sequence of characters and uses the char class. So char is a single character represented as a decimal number and then encoded in a way so the computer knows exactly which character to display. A string is a sequence of those. So we have some data structure with a sequence of characters, and that's going to be a string. And then the string class has more methods to be able to work with those characters, with that sequence of characters as a convenience for us. Yes?
So in the instance of creating like something like a function or using the main method, when you do the input in a string, do you do string or do you have to use characters made up?
You would do string. So there's a string, so there is a string class that exists. So maybe that was misleading when I say string doesn't strictly exist. But there is a string class, and that class stores a variable, which is a sequence of chars. So we would say a string in there. But the point I'm making is that string is kind of a made-up thing. There's a class that's in the library called a string that has a sequence of characters in it. There's no special data type called named a string. It's just something that's made for us, for our convenience mostly. And we'll see lots of classes like that. String literals, double quotes. Python and JavaScript allow you to use either single or double quotes. It's not true in Scala. It's all double quotes for string literals. If you use single quotes, you can use single quotes for char literals if it's a single character. But even then, I'd recommend using them as strings. You can get into some issues if you use single quotes and use chars. We have a few methods here that you would expect to see with strings. The one we'll use for the lecture question, this dot split, I linked directly to that documentation on the course website so you can see exactly what the dot split method entails. You may not have seen that in 115, so let me spend a little bit of time on it. So split is going to take a delimiter, and it's going to split your string on that delimiter and return a data structure of strings that are the values separated by that delimiter. So when you get your strings in that file and those values are separated by the delimiter of the hashtag, you would say split the string on the hashtag. It's going to return a data structure of just the values that you're interested in. And then you can iterate over those values and then sum them up for the lecture question. It's a very handy method. It exists in most major languages where you can chop up a string based on some delimiter. Yes?
What type of data structure does it?
I think we have it on one of the slides here. I believe it's an array, but we'll see when we get there 100%. The question was, what type of data structure does split return? I believe it's an array, but we'll see for sure in a slide or two. We can also convert between these types fairly simply, depending on the types. Scala will let us convert between them using this syntax, this method of to, and then whatever type we want to convert to. So if I want to convert this value, here I want to convert this string to a double, I'll just say to double, and it's going to convert that for me as long as it's a well-formed double. For example, if this was the literal string spelled out 6.3 as in SIX space PO, spelled out, of course it's not going to convert that because it's not a well-formed string, well-formed double. But as long as it's able to convert it, to double is going to convert that string to a double. There's also to int we could convert. Converting anything to a string, we have the toString method. To int, if I want to convert a double to an int, I can do that too. Just know that you're losing that precision. It's going to truncate the decimal portion of the double completely. You have to be careful with the converting doubles to ints. If you have that loss of precision, and it goes in the other direction that we didn't see, so instead of having my 0.3 be 0.30004, if it's 0.2999999, and I convert that to an int, I'm getting, that's a bad example. I meant if it was, let's times that by 10. So instead of 3.0s and then 4, I got 2.9s. If I got 2.9 and I do 2 int, that's going to be a 2, not a 3. So we got to be careful. It's always going to just truncate the decimal, just throw it away and keep the whole number. So just something to be careful about if you're going from doubles to ints. So in most cases, if Scala is able to convert between types, you can use these methods, these two, whatever type you want to convert to, methods to be able to do that conversion. Syntax for a for loop is a little different than you've seen, at least the for each loop, which we have here. The for each loop, a little bit different. We have this arrow instead of, not too different really. In Python, you would have variable name and then the literal word in, and then your data structure. Here, instead of that, we have an arrow. So it's a less than sign and then a dash to form an arrow. And Scala will use these fairly often, fairly all over the place, these little arrow syntax. So this reads, for variable name in data structure, execute this loop body. So not too much of a departure from what we've seen. Using them, things get a little bit different here. One, if we just want to loop over, we want to write the very basic first loop that you'd see, and we just want to print out some numbers in a sequence, we can use this to method and say 1 to n. That is going to create a data structure, and we're going to iterate over that data structure. So we're still following the syntax from the previous slide, where I have some variable, I'm going to name a variable, and then I'm going to iterate over a data structure. I'm still doing that, but my data structure is the return of this expression right here. To make that a little more explicit, I rewrote this and said 1 to n, and then stored that data structure in a variable, and that type of that return value is a range, and then I can iterate over that range. So just to pull that apart and show you what's happening there, we're creating a range data structure which can be iterated over in a for each loop as a data structure, and then I'm iterating over that data structure that contains those numbers from 1 to n. Then, of course, this will print the values I equal 1, I equal 2, all the way up to 9. This is similar to range in Python. You've seen range in 115? Same thing as that. For x in range of 10, that would be the same thing here. So let's combine some of those, and yes, I know this is going fast. I expect you to really learn this stuff during the lecture question. So I know this is going fast, but let's start combining those topics that we've just seen and have a little example where I start with a string, which will be various true or false values separated by semicolons. And what I want to do here is compute the percentage of true-false values that are true. So if I run this program, I would expect 80% to be printed. I think I'm just printing it to the screen. I would expect percentage true to equal 0.8 for 80%. So that's what I'm expecting here. Let's step through this and see how we're doing that and what's happening here. So this example, I'm throwing a bunch of code at you right up front. So let's take a few slides, digest this, and see what's going on here. So first, I have my main method. This is where my program is going to start. I have my input that I'm going to test this thing on, call my method, and then print out the return value of that method call. So the first thing I do inside this method is use that split method that we've seen. So split is going to take a string. I'm calling it on a string. It's going to take a string and split this string by this delimiter. When I have this array, what's stored in this array are going to be the strings true, skip over the delimiter, false, true, true, and true. So I have 5 strings in this data structure, which are the values true, false, true, true, true. I'm going to iterate over those strings, and for each one of those strings, I want to convert it to a Boolean to be able to get the Boolean value instead of the string value out of these strings. Yep.
So you don't need to declare the variable you use for
No. So the question, I don't have to declare the variable I use for the loop. No, it'll be automatically declared. I don't have to use var or val for this. So I'm going to iterate over these values, and for each one, I want to convert it to a Boolean. I have a string. I know that they're all well-formed Booleans, at least in this case. I should have some type checking if I'm using user inputs or strings that I don't know where they came from. But I'm going to assume in this case that they are well-formed Booleans, that nobody's given me capital T's or any of that stuff. and convert them to Booleans using two Booleans. For each one of those Booleans, if it's true, I'm going to increment my true count. I found a true. And whether it's true or false, so outside of this if statement, I'm going to increment the total that I've computed, that I've seen. I'm going to divide it, so simple average. How many of them are true? How many of them total? Divide. So I have to be careful here because the total count and true count, while these are always going to be integer whole number values, I still have to be careful when I get to this division. I don't want this division to be integer division. If I'm doing this with integers, if those are both ints, this will be integer division, which is going to return an int. That means it's going to compute the division and then truncate the decimal, which is either going to return 1 if all of the values are true and I have 1 divided by 1, or 0 otherwise. Everything else is going to be 0 because it's going to compute some fraction, 0.8 in this case. It's going to convert it to an int and just drop the 0.8. We want to avoid that integer division. We don't want this to return an integer. So I avoided that by declaring both of these as doubles. Now this is going to be a double division, and I'm going to return that as a double. Instead of having integer division, have that be interpreted as an int, and then converted to a double to be returned. That would lose my precision, and I would just be returning 0 here. So I have to make sure this division is a double, a floating point division, a double division, not integer division. Question? Oh, yeah, good question. So when I declare and initialize total count and true count, why did I use 0 instead of 0.0? I usually do use 0.0 just for clarity to make sure everybody knows those are doubles. When I put 0, that 0 is an int, and then Scala will convert it to a double when I assign it to the variable. So Scala takes care of that for me, where in Java, I believe this would be a syntax error. It wouldn't let you do that. So I'm getting away with that just because Scala is doing an automatic type conversion from int to double to store in my variable. But yeah, and for clarity, I usually do that. I missed it on this one. Reading files is similar to reading files in Python in that we're going to pull in a library. We're going to use that method inside that library, and that's going to do most of the work for us. And we're going to iterate over our file line by line. So in this case, we want to read this file line by line. In this method, we're going to open the file, read it, and then just concatenate all of its contents into a single string. I just want a single string with all of the contents of the file. So something not particularly useful, but just to show how to open up files and how to work with them a little bit. And to see string concatenation, plus sign, just like in the languages in 115, we can concatenate these strings. So to do this, the first thing we need is our first import statement. I want to pull something from Scala's standard library. There's a lot of nice code in there, and I want to use it. I'm going to use this scala.io.source. I'm going to import that first, and then I can use that object in my code. So source is a Scala object. It has a lot of nice methods that can help us out, and we're going to call those methods that are defined in that class. And this is something that we'll do in a lot of the homework and a lot of the assignments. In your lecture question today, you're doing that same thing. This is the other side of that. Somebody already wrote a method, and we're going to call it. For a lot of your assignments, you're writing an object that has methods that somebody else would be calling. Somebody else is going to call. And your homework 1 is a great example of this. Most of homework 1, you have this physics engine class that I give you. It's empty when I give it to you, and you're going to fill it in with a variety of methods that other people can call, that my grader code is going to call, that your testing code is going to call, to be able to make use of the physics engine itself. But the physics engine is going to be an object with a bunch of methods inside of it. So source is an object with a bunch of methods inside of it. One of those methods is this from file, which is going to pull up a file from disk, load it up so we can start working with it. I can just say for line in source.fromFile file name. But again, I want to split this into 2 lines to show you what's going on there. The source.fromFile method is going to return a buffered source. The buffered source is what we call iteratable, which I always have trouble saying, which means that we can throw in a for loop and iterate over it. So we can iterate over a buffered source, and I'm going to, or we can iterate over the get lines of a buffered source. We can do source.fromFile file name.get lines all right here. So this buffered source, I'm going to call the get lines method, which is going to get every line from the source, and I can iterate over those lines as a data structure. So it's mostly syntax. Import is the new concept here. Beyond that, it's similar to what you've seen in 115. So here's the code that we just saw in the slides. One very important thing I want to make sure I mention, because I've seen far too many students miss this part. It's a little tricky. It's a little bit of a kind of a finicky thing with IntelliJ, I suppose. But when you open a file by file name, when you run this program in IntelliJ, it's ran from the root folder of your project. So when I run this file, it's going to start in this folder, my top level root directory of my project, not from the folder where you're calling the object from. It's an important distinction because when I create this test file and when you want to test your lecture question code today, when you write a main method and you want to make sure it's working, you submit to AutoLab on a hope, it gives you a 0, and you flag me down and I say, well, did you test your code? This is what you want to do. When you test your code, write your main method like this, go to your root project and create a file with the file name that you want. So here I have in my root directory of my project a folder, I know the sidebar is hard to see, but a folder directory named data, and then a file named testfile.txt. That's where this file lives. Then when I run this code, it's going to look for a file in the directory data, a file named testfile.txt, starting from the root folder. And when I have that, I get my file here. If I have anything else, if I have even a single character typo here, what I'm going to get is a file not found exception. I'm going to get an error because I tried opening a file that doesn't exist. This is where, we don't do that in 115 anymore. This is where, if you use Java, if you did some Java, this is where we would have a try-catch block that would catch the file not found exception. We're not doing that in Scala. It's just Scala doesn't want to do it like that. So file not found exception, that file doesn't exist. If you see this, it means the file that you're testing with isn't in the right directory structure. It's not exactly where you told your code to look for that file. So make sure if you see this, check the exact string that you're testing with. Start at your root of your project and make sure you can find that exact file based on that exact string. If it's not there, then you know you have a problem. And I have you know what to check, you know what to fix. So I have the file, the text of the file here. When I fix that file name, I'll have that exact text, of course, in my program as well. So I'm going to that file on disk, loading it up, reading the lines, iterating over them, concatenating together, returning that, and then printing that to the screen. And finally, data structures. There are a ton of data structures in Scala. These will make more sense in a few weeks. We'll talk about inheritance trees and what this really means. But there are a lot of options for data structures. We're going to simplify this a bit and talk mostly about 3 data structures during the course. And even array, we won't talk about too much throughout the course. But list and map, we will talk about extensively throughout this course. So list and map, this is similar to your list and dictionary in Python. It's similar to your array and object in JavaScript. So we're going to stick with those 2 data structures, at least for a good chunk of the course, until we get into trees and graphs. We'll talk about a few other data structures built off of these. So let's talk about these 3 for now. Array is a sequential data structure that's all stored in one continuous block of memory. So when I declare an array, when you declare an array, you have to know its size. And your operating system is going to ask, or your program is going to ask your operating system, or the JVM is going to ask the operating system rather, for a chunk of memory that is exactly that size. You'll get that chunk of memory, and then when you want to access a specific value, you'll go to the first address in that block of memory, and then add to it whatever the size of each element is, and all the elements have to be the same size as well, times the index that you want to look for. So if I want the value at index 0, it's just going to be the first address. If I want the value at index 3, I'm going to times the element size by 3, add that to the first address, and jump to that exact element. So I can, at any point, access any element in the array with what we call random access. I can access any value just by doing a multiplication and an addition and getting that value directly from memory. Because the block of memory has to be continuous, we cannot increase the size of an array. An array is fixed size. Many languages have ways to resize arrays behind the scenes so you don't have to feel the pain of this. But an array cannot increase in size because that next memory address might already be taken up by some other data. So arrays in Scala, we'll go through each one of these. I think they speak for themselves. One thing I want to point out is using the to method, 0 to array.length. We can iterate over the indices of the array. So you can see an application of that to method. I want to iterate over some numbers. Well, what are those numbers? Well, here they're the indices of the array. Or Scala takes it one step further, makes it a little easier. And you can just do array.indices, which is going to return the same thing. An iterable of 0 to length length minus 1. Next we have lists, and this is the one we'll probably talk the most about in the class, and we'll even go behind the scenes, see how a list, which is based on a linked list, is created, how it's stored in memory. We'll create our own linked list and see how that works and write some algorithms to work on linked lists. We'll talk about this one extensively later in the semester. This is a sequential data structure just like an array, except it's not one continuous block of memory. The way a list works is we'll have linked list nodes, which are separate values, separate locations in memory. They'll be scattered all across memory. And when I have the first element of a list, that element will store the value, the first value in the list, and also a reference of where in memory you can find the next value in the list. So I can take that reference, jump to the next value, and at that value, I can find the reference for the next value, and then just keep jumping all over memory by following these references to be able to get where the data that I need or iterate through all of the data in the list. This has some advantages and some disadvantages to an array. The one big advantage is that a linked list can grow and shrink in size. Since the memory is not continuous, I can just ask my operating system for another chunk of memory anywhere in memory, and then just point to that new memory from my existing list. To work with these in Scala, a little bit different. We can get the first element very quickly, but since we have to jump around in memory a lot, to get a certain index, linked lists don't really have indices, so if we want to pretend to get a certain index, we would use this apply method which is going to start at the head, follow its reference, follow that as many times as you give it the apply method to find that value in a list. We have a little bit of new looking syntax here to append to either the end or beginning of a linked list. And iterating is how we would expect. Iterate over a list using that for each loop. It's iteratable, so we can use the for each loop with the same syntax. And finally, a map. This is our typical key value store. We're going to store keys that map to values. These can be any two types here. Oh, I didn't mention that. I'll have to mention that in this example. This is based on a hash map. That's a CSE 250 topic. We're not going to talk about how to implement a hash map or what that involves, why we would use a hash map. But just suffice to know that by default, these maps are implemented on top of a hash map. We can change the size, we can change the values, we can do anything to this map. One difference I forgot to point out in the other two examples is these type parameters. This is an important part. I'm glad I remember this before the end of the lecture. These type parameters, when I declare a data structure and other classes as we get further down the road, when I declare a variable of type map, I also have to give it the type parameters to say which types this map is going to store. So in this example, I want to create a map from integers to integers. That means the keys and values have to both be integers. This is very different from Python and Python and JavaScript, which would let you mix and match values. In Python and JavaScript, you could have a list or array of doubles, ints, strings, other arrays and lists all mixed in together in the same data structure. That is no longer true when we're in the world of Scala and strong typing. We have to specify what type these data structures store. So this list of int, for example, can only, throughout its entire lifetime, can only ever store ints. Can't store any other type. So I can only put ints in this list.
I have a question.
Yes?
So for the arrays, I know you put two, okay, so you just put the type of the data that you're holding in the square brackets for when you declare an array?
Yes, for the type parameter. Right, yeah, so the type parameter, the syntax is the same for array, list, and maps. That we have these, the square brackets, and we're going to put that type parameter inside that when we declare the type of this variable. Iterating over a map, we have this convenient way to iterate over keys and values at the same time. You can still do .keys, .values, and things like that. But when we have this convenient syntax, why not use it and just always iterate over both? That's my opinion. You can iterate over them however you want. But it's very convenient to iterate over keys and values at the same time. So whether you need both or not, it's pretty easy to do it, so why not? If you try to access a key from a map using the array syntax, and that key is not in the map, you're going to get an error. It's going to say key not found or whatever the error says. It's going to crash your program. To get around that, if you want to want to have a safe lookup in a map, you can give it a second parameter and use get or else. Use this method with a default value. Now, if 100 is not in my map, which it's not, this is going to return -1 instead of crashing, which is a very helpful thing to use. And finally, back to the lecture question. I'll walk around and get to you. So back to the lecture question. I have 4 minutes to walk around, and I'll hang out after class answering questions. But that's what I have. So have a good weekend. Have a good Labor Day. No class on Monday, and I'll see you Wednesday.